Hang on, it's on air. Share screen. Okay, again, so go to your dev directory, fire up Vagrant, Vagrant up, get that up and running. So when we get to the coding exercise, you guys aren't waiting for that to happen. And you can even Vagrant SSH into that machine, that virtual machine, because we'll be doing a lot in the virtual machine today. Okay, we'll be doing a little bit in Sublime as well, so you can get that going if you want. I'll give you guys a couple minutes to get that going, because after you guys kind of get that going, I want you to really pay attention to what I say today, because there is quite a bit of theory today. Still coding exercise, because we said every class would be a coding exercise. There's quite a bit of theory to understand today. And if you've never done databases and you've never done a full stack application, what I mean by full stack application is generally user interface to Java classes to database. That's like a full stack, okay? And whatever that user interface could be different. If you've never done a full stack application, this stuff will be slightly more complex to understand. So I really want you guys to pay attention to that. If you've done has anybody here done a full stack application? Okay, so only a couple of you guys. So for the rest of you guys, sit back, pay attention while those things are firing up. I know it's hard. You have a computer in front of you. You want to pay attention to that. So I'm going to try to, as much as possible, keep your attention on that, okay? And all this is right after I said, get your machines up and running. So I'll give you a couple minutes to just get those up and running. And then I really want you to zone in and pay attention to this. I would say this one and 2 lectures from now are the hardest to understand. Okay, this one today is going to be one of the more complex ones. 2 from now gets quite complex, actually. 2 from now gets very heavy into theory, a lot of stuff to get in there. So just to show of hands, how many people were able to finish the exercise last week and get their home page showing? Good. How many people did the homework and added an about page? Nice. How many people did the homework and added a contact page? Okay, less, but okay, that's good. Okay, so again, talk amongst yourselves. This is also a networking event, so share your experiences, try to get that going. The big thing from last week to remember is the Rails routing experience. So let's review that for a little bit, guys. When a web request comes into Rails, okay, what is the first file that's hit? Roots, right? Roots.rb, okay? A Shopify sticker. Or do you want a different sticker? All right, so the very first thing it hits is the roots. Roots.rb. Can you tell me what the roots.rb does? Good. Connects with the controller. Okay? So the routes basically tells you when a request comes in, what controller you're going to go to. It also tells you what method inside that controller to go to. Okay? What do we call methods inside controllers?
Actions.
Actions. Sweet. You really want that sticker. Give you an Ember sticker. Ember is a very cool framework, by the way, especially for Rails developers. So the routes file takes a request that comes in and says what controller to go to, what method in that controller to go to. Okay? Then in that method, we do any kind of server-side processing we want in Ruby code. Okay? And the very last line of every method, we call a Rails method. What's that Rails method that we call? Render is what I was looking for. Yields a different thing. Render. Who said that? You can give a what did he said? We call the render, okay, which renders the page inside the yield of your layout. Right? So that is very important to remember. And remember, this is all in the context of web requests and responses, right? That was the very first thing we learned. Okay, that's built on this whole HTTP protocol. And the way we initiated our requests last week was by entering them into the URL bar and hitting enter. That initiated the request. Or we clicked on a link. That initiated a request, hit our Rails routing, and spit it back out. Okay? I really want you guys to remember that Rails routing, okay? And the reason I really want you to remember this time is we're going to leave it alone for this week, okay? But starting the next week, we're going to come right back to it. So you got to burn that into your head, okay? Request comes in, hits the routes file, goes to the controller. You do whatever you want in the controller action, and then you render a view, and the view gets spit back to the browser. Okay, you got to really remember that. Okay. Now, one thing that I should say, and if you don't remember this, it's not a big deal because I'm probably going to say it a couple times. One thing I should say is that the way we coded it, okay, if I open up my code here, so Rails projects, tutorials, my website. If I look at my code here, right, we were mapping a certain request to a certain controller and a certain action, right? Then we went to that controller and we coded that method or that action, and then we rendered the view template, right? Now, in our case, we happen to name everything the exact same way. /home went to the home action and rendered the home template, okay? I don't want you guys to think that is a must, because that is not a must. You can do whatever you want. You could have said /toys goes to the ham action and renders the steak template. You could have done that, okay? You could have just as easily done that. But you'll learn a little later on, there's a little benefit in naming things the same way, okay? But there's no rule saying that you absolutely have to do it, okay? All right, so that was last week. So remember, request comes in, hits the routes, controller, view, spit back. Always keep thinking that, okay? And again, every Rails application is this way. So when you go code somebody else's Rails application, or you get hired for a job to go code a Rails application, somebody says, oh, can you go fix that page with the / whatever? You know where to go. You go to the routes file. You find, oh, that goes to this controller. Oh, it goes to that action. You can read it. This is the beautiful thing. You save like loads and loads of time because everyone who codes a Rails application codes it the exact same way. Or if they know what's good for them, they'll code it the exact same way. Okay? Cool. Any questions about what we've learned so far? Okay, you guys have learned a boatload, and you kind of code a whole lot with this. You can code a bunch of pages. You can code an entire website with what you've learned just now, to be honest. But we're going to code Web 2.0 applications. We're going to get a little further than that, okay? So what I want you to remember today is that we're just taking a little aside. We're just going off in a little bit of a different direction, okay? So it may not seem obvious that we're using what we're building today inside our app, because we're not actually going to put it into our app today. We're just going to code what we need today as our little tool, okay? And then we're going to use it in our app coming the following lecture, okay? So just a little tool that we're going to code up today, and then we're going to use it back in our app, okay? But don't forget about the big picture. Request, response, request, response. Okay, so again, we got a good understanding of how Rails handles web requests. We coded our controller, we coded our action, we coded our view template. So now we're going to code the Rails model. Okay, we're going to code the Rails model. So the theory today is what the heck is a Rails model? We're going to go over what a Rails model is. And to be honest, this theory translates to most MVC applications in terms of what the model is. Okay? All right. Conceptually, a Rails model is basically a representation of a single entity. That sounds so like abstract. If you're coding an application, okay, that sells products, that invoices customers, that tracks purchases, okay, you will probably have a model that represents a single product. You'll probably have a model that represents a single purchase. You probably have a model that represents a single invoice, okay? Most first and second year Java programmers go through this exercise. They give you a word problem. They say, underline all the objects, and you're going to create classes for these objects, right? That's typically what gets changed into a Rails model, are these objects that you underline, okay? So if you think about, we're going to code a fitness tracker that's going to track calories, okay? You may have a model to store, you know, calorie counts or whatever, to store the log of how many calories per day, things like that, okay? So what a model is basically a representation of some single entity, okay, in your problem that you're coding. So again, here's another example. If you're building like an online store, you probably have users, right? You probably have a model for users, model for products, model for purchases and invoices. This is why you go through these exercises in undergrad. They're very useful. Eventually, you get so good at it that you can just identify every object that you think that you're going to code. You don't even have to underline them. You don't have to map them out. You just know every object that's going to be created. Okay? Now, programmatically, there's a couple things you want to know about models. Okay? So a model typically is a class. Okay? How many people here know what a class is? Good. Whose instances represent a single data entity. Okay? How many people here know what an instance is? How many people have ever used the keyword new in Java to instantiate? Good. Okay? When you instantiate an object, or a class, right? You're creating an object, all right? The Rails model, that one object will typically represent a single entity. So that means if you're creating a model for products, you would have a class called product, and the instances of that class would represent specific products. Okay? Kind of sounds like basic object-oriented 101, right? If you create, a car class, right? Instances of that car class are specific cars, right? So this is really nothing new, okay? It's just you're representing these conceptual objects programmatically, okay? Now, here is the one little catch. Here's the one little nuance for the people who've never coded a full stack application. Okay, how many people in the room have coded a Java object before? How many people have coded a Java object called car? Most, yeah, okay. How about truck or vehicle? How many people use that as their example when they're interviewed about jobs? It's always like, oh, give me a hierarchical thing. Oh, you could have a vehicle class and it extends car, whatever. Okay. Again, how many people have instantiated a Java object class before? Good, okay, most of you, okay? Now, how many people, when they shut off their computer and shut down their Java application, and then they turn on their computer and run the Java application again, is that same instance there? Not many, right? Most of the time when you shut down your Java program, all your instances are gone, right? So most of the Java programming you do is what we call in-memory Java programming. You instantiate the object in memory, right? But as soon as you shut down the Java program, that instance is gone, right? A lot of times you can fire it up again and you can create it again, but usually when you shut it down, it's gone. So there are a couple of ways we can kind of solve this problem, all right? We can write this information to a file. How many people have ever written information to a file from a Java program? Okay, some, okay? That's one way you can store this information. So what you can say is, if I create a car and it has properties blue, shiny, made in 1997, right? You can write that information to a file, right? So you can create a Java class that says, like, I have an instance method called save, and it writes it to a file. And then you can have a piece of line of code that says, read from that file and load up your Java object again, right? That's one way you can do it. If you've never done that, that's okay. We're about to show you how to do this kind of stuff, okay? But that's one way you can solve your problems, writing it to files. And for the longest time, when I was in software engineering undergrad at Ottawa U, I was like, when are we going to get to this? Every program I interact with, Microsoft Word, Adobe Photoshop, I guess at that time, like Notepad and stuff like that, I was writing all these, I was interacting with all these programs, and none of my programs did what any of these programs did. They never saved to a file, and I could bring that file up again. So for the longest time in undergrad, I was so frustrated because I was like, man, I'm creating programs, and none of these programs are actually usable because as soon as I shut down the program, I lose all my information, right? And that was until I hit databases. Now, when I hit databases, like, this is weird. Why are we putting so much emphasis on databases? Why do people tell us about databases? Because every program I interact with, again, just saves information to a file. I never save things to a database, right? But the reality is, a lot of applications that you interact with today save things to a database, okay? Facebook, Gmail, a lot of enterprise programs, okay? They save information to a database. Now, for those who are a little curious, a database ultimately in the end is really just a file. It really is, you're just writing information to a file. But a database has some logical structure to it. So you're not just writing bits of information to it, you're storing it in a logical way that you can retrieve it and write to it and so on and so forth. Okay? So this is the subtle nuance with Rails models. You have a class that represents an entity, but it also interacts with the database to save that information over time. So that if you shut down your computer, that information is stored somewhere. Okay? For those, again, who've never taken databases, this is what you'll be programming in your database courses. You'll be programming a Java class, okay, like person, that has name, age, all those kind of things, right? Those properties. You'll be programming a class called person that does everything that you guys know today, but you'll be adding some extra methods to that. You'll create methods, okay, that write the information from that instance to the database. So you'll say things like, oh, save my name into this column, save my age into this column, save my whatever into this column, and that's what database is all about. Okay? So database is all about saving your information. Unfortunately, we do not have time to get into databases and the database language, but just know that this is the theory, that the model is an in-memory object that has methods to write your information to a database table. Okay, how many people understand that? Okay. Good. That is the theory behind what we're doing today, okay? Is we're going to create a class, and we're going to create methods that say, whatever's stored in my instance variables, like age, name, all this stuff, we're going to write it to the database. We're going to write the language to execute a command that inserts that information into the database, okay? In case you're curious, and for those in the room who actually do know databases and do know the SQL language, okay, your methods are basically executing SQL statements. Okay, you're basically, when you say like my object.save, you're writing a SQL statement, like insert into this table, this column, blah, 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 and you're executing that SQL statement. If you don't know what SQL is, don't worry about the slide. Okay, so remember this model. This literal model here, okay? That we are going to create a class that has methods to write itself to the database, or even smart enough to grab information from that database and instantiate that, that model. Imagine how great it would be if instead of every time you fire your program and typing person A equals new person with all the constructor parameters in it, that you could just say, read those parameters from the database and instantiate my object. Okay, that's where we're headed. All right, so here's another example, okay? Again, back to our e-commerce example. You have users, you have products, you have purchases, you have invoices. So you'd have a class for each one of those, and you would have a table for each one of those. Sorry, I didn't really clarify. A database is just a collection of tables. And in those tables, you have columns and rows, right? So the user would store rows of users in the users table. Product would store rows of products in the products table. Okay? So, after all that is being said, what a Rails model is programmatically, it is a Ruby class and a database table. That's all a model is. Okay? It's a Ruby class and a database table that interact with each other. Okay? Good. All right. Some coding conventions, very important. The Ruby class is always singular. And remember, classes are one of the rare things in Ruby that are upper capitalized camel case. So things would be like user, product, invoice, purchase. If you had something that had two words, like log entry, it'd be capital L, log, entry with capital E. The database table is always lowercase, underscored, like everything else in Ruby. Classes are the only things that are uppercase capitalized camel case. Database table is lowercase, plural, which kind of makes sense if you think about it, because the purchases table stores many purchases, right? It doesn't just store one row of purchases, right? It stores many purchases. But every instance of this would be a singular purchase. Kind of makes sense why it'd be singular. Okay? So by the way, we've seen coding convention over configuration. Here's another classic case of convention over configuration. If you name things properly this way, you name the model user and you name the table users. If you name these things properly, you don't have to tell Rails anything else. It'll know how to hook that up. Okay, you don't have to tell it which table you're inserting to. It knows from the name of the model. Okay, it knows how to pluralize that and find that table. Okay, Rails is scattered with so many examples of convention over configuration, which basically means you follow our conventions. You don't have to configure anything. We'll configure it for you. Okay. All right. So Rails models consist of two things: a Ruby class and a database table. Right? I want everybody to say it. Ruby class and a database table. The Rails model consists of two things. Ruby class and a database table. Okay, that sounded awfully boring. I don't want to sound like a cruise director, like pumping up the crowd. So let's wake up, because I said a lot and there's a lot of theory and you guys are going to sleep. So a Rails model consists of two things.
Ruby class and database tables.
Nice. So what I want you guys to do is go forth and synchronize your chanting, because it sounds awful. Okay, awesome. That's what a Rails model is. Now, how do we actually code these things? We could code it by hand. Most times I say you should code it by hand. But a Rails model is one of those things that always has these, not always, sorry, 99% of the time has these two parts. It always has this Ruby class, always has this database table. Okay? So rather than us coding it by hand, the way we coded the controller, we are going to use for the first time a Rails generator, a Rails code generator. Rails ships with a lot of code generators, by the way. And the more you get to know them and the more you get to use them, they're really, really awesome things. But out of the gate, I'd say they're kind of dangerous to use them, because if you don't understand the theory behind it and you don't understand what is actually generating, you can get you into a lot of issues in the future. Okay? This is one case where I think it's pretty simple actually to use the generator, because you're basically using a generator to spit out two things: a Rails model class and a database table. Okay? So it's going to create a Rails model class and a database table. Now, here is yet another catch. I told you it would be a lot of theory. Okay? Here's another catch. I said I'll generate a Rails model and a database table. I'm going to tell you guys a story about how we used to code before frameworks like Rails came along. Okay. What's your name?
Kevin.
Kevin. So me and Kevin get assigned a project, SEG 4900. What is that class? Is that a class even? 4900? Not a class. It's an awesome class that you guys will get to take if you're the best of the best. SEG 4900, me and Kevin, right? Me and Kevin get assigned a project, and we're going to build a full stack Java application. So me and Kevin start coding our objects. We call it a person object, a product object, and things are going pretty well. We're even pretty good with our source control. Kevin checks in his source code, I review it, do pull requests, all that jazz. It's really good. Things are going pretty well. Now, the one thing that's separate on two of our machines, though, is our actual database. Okay? Databases are applications that you can run on your machine. Postgres is one of them. Microsoft SQL Server is one of them. These are actual programs that you install on your machine, and you interact with them. So Kevin installs Microsoft SQL Server on his machine, and I install Microsoft SQL Server on my machine. And we're coding along, and Kevin creates a class. And Kevin says, oh, hey, Casey, I just coded the class for what object? Product. Okay? He coded a product object. And he says, oh, Casey, by the way, I'm gonna follow our conventions, and we're gonna put this stuff into the products table. So he sends me an email or message on Slack, and he's like, Casey, I coded the product table. You can check out the code here. I'm like, oh, awesome. The code's awesome. So what do I need for the database table, Kevin? Kevin's like, oh, there is a users table. And for this one, there's a products table. So make sure you have a products table. And the product table needs to have a couple columns. It's got to have a name column. It's got to have a SKU, a part number. It's got to have all these columns in it. I'm like, okay, awesome, Kevin. Thanks. Appreciate that. Kevin codes another class. Codes a car class. He says, Casey, oh, there's another table gotta get you to code. Cars class, and there is 2 columns in it. Color, make. Okay, so Toyota, Subaru, whatever. Okay, awesome. Kevin sleeps that night, and he gets a spark of inspiration at 3 in the morning. He's like, wicked. No, we're going to make this revolutionary app. We're going to create something called tweets. And all they're going to have is a 140-character database column and tied to a user ID. That's all we need. Okay, sweet. He starts to get coding, and he codes it, and he's done. Checks it into the source code. And he's like, I'll tell Casey about that later. I wake up. I check out the code. I don't bother to look at the code that he's changed because we have 10 other people working on this code base. And I start coding, and all of a sudden, I run this piece of code that tries to insert a tweet into the tweets table. I'm like, what the hell is a tweet? What is this thing? Like, this is ridiculous. And I'm like, I have to go through his source code. I'm like, oh, there's a tweets table he's trying to insert into that I don't have on my database. I messaged Kevin. Kevin, did you code this weird thing called the tweet? He's like, yeah. Oh, I forgot. Give you the tweets table. I'm like, oh, right. Okay, I'll code the tweets table. That's just me and Kevin on 3 or 4 very simple objects. You can think about 140 objects, massive apps like Shopify. How the heck do we keep control of this database stuff? Okay, because the database is not actually in the source code, right? The database is not actually in the source code. Your source code connects and communicates with the database, but your database isn't in the source code. Okay. Now, programmers of Rails realize this, and a lot of other frameworks. I shouldn't just give Rails credit, but Rails was one of the first ones to realize this. And they said, this is so messy. It's so messy because our source code is nicely controlled, but our database is all out of whack unless we email each other and keep in contact with each other. So Rails came up with what are called database migrations. That will play a huge factor in your guys' coding. Okay? Database migrations are instructions to create tables and destroy tables and alter tables. It's a little script that you can run on anybody's machine to create those tables, destroy tables, and so on and so forth. And as long as I have all those scripts, I'll know how to create my database and keep it up to date. Okay? So when we code today, we're going to be coding a Ruby class, and we're going to be coding a Rails migration. And then that migration we're going to run to create the actual table itself. Does that make sense? How many people does that make sense to? Okay, not too bad. We're losing some people, but we'll get there. Now, because of this, I want you guys to remember, any edit at all you do to the database schema. What I mean by schema is the structure of the database. Not the data that you put in there, but like the columns, the tables that you're using, the names of the tables, everything you're doing to the database structure, don't do it directly to the database structure. Because you'll have to remember to email your entire team to say, do this exact same thing. Okay, don't do that. What if a new developer comes in? They have to remember all those emails? No, don't do it that way. If you're ever thinking of adding a new table, removing a table, renaming a table, adding a column, changing a column type, any of those things, always, always, always do it through a database migration. Because database migrations, we do check in to the source code. So that is code that everyone will have. Okay, and they can just run the migrations and they know the database table is up to date. So if Kevin adds 2 more tables, he creates migrations. When I check out the code, I'm like, oh, there's 2 migrations that I have to run. I better run those. Database migrations, okay? Told you it would be pretty heavy on the theory today. All right. This is a small slide, but this is more for your reference. We're going to go through it, okay? There is code generators, like I said, that Rails ships with, okay? And they all start with Rails generate. So if you want to run any generate command, you do Rails generate. Just like if you want to run the server, you do Rails server. I had a question the other day asking, oh, do we have to start up an Apache web server? No. Rails server starts up your web server for you. It ships with a web server built right into it, okay? So Rails generate, and there's a whole bunch of generators. The one we're going to use today is model generator. So you do Rails generate model, okay? And then you pass it a bunch of arguments for what your model actually is. You give it the model name. Is the model name singular or plural? Singular. Good. You give the model name singular, and then you give it a bunch of attributes. So it'd be like Rails generate model product. And then the attributes would be like name, color, part number, price, stuff like that, right? So you give the name of the attributes, lowercase underscore, and then colon, the attribute type. Things like string, int, float, decimal. There's a lot of types that actually the Rails model generators will know how to deal with. So what that'll do is it'll generate your Rails model for you, and it'll generate the migration script to create the table. Now here's the really cool thing. The Rails migration script that it creates is database agnostic, 99.9% of the time. Okay? Which means that if you're running a Microsoft SQL Server database, or a SQLite database, or a Postgres database, it's the same script that runs. Okay? So that's what we're going to use. It's funny I asked that question, and the answer is like right there. So that will generate two things. Remember those two things we talked about? A Rails model and a database migration. This is where it stores them. Creates a model in app/models, creates a database migration in db/migrate. So we have our migration script, we have our database model. Okay, does that make sense? Yeah, nods? Okay. 7:38, we're still good. Okay, let's talk a little bit about the Rails model that gets generated. How many people here have ever coded getters or setters? Sweet. When you create a person class, can somebody yell out a example getter?
First name.
Good, get name. Get first name, great. Somebody yell out a get age, that's good. Somebody yell out a setter.
Set name.
Set name, good. Okay. So those are getters and setters, right? And those typically access private variables, right? We have an age variable, a name variable, and so on and so forth, right? Okay. That's what a Rails model is very similar to. So if you're going to create a product class, you better have a getter and a setter, okay, for all the things you want to store on it. Name, SKU, part number, color, whatever. Okay? So that's what a Rails model class is. Now, again, it'll have some extra methods. Things like write myself to the database. Okay, there'll be a method that says write all my private variables to the database. Okay? How many people here have ever coded a class method or a static method? Are those the same in Java? Yeah, okay. Just want to make sure I haven't done it in a while. Okay, remember class methods are things that you call on the class itself, right? Not on instances, right? So typically, if you think about, if you have a product and it has a bunch of variables in it, you might want to set some values on it, right? So you have a product.setName, product.setAge, right? If you instantiate it, brand new product, okay, you would do like the product equals new product, throw in a bunch of parameters to the constructor if you created a nice fancy constructor, right? It's all good. Now, one thing that you guys might not have dealt with, if you've never done a full stack application, is how would you get the information from the database, okay, and instantiate an object with that in the first place, right? So if you can picture in your head, okay, well, maybe what I'll do is I'll instantiate a brand new object, so new product, right? And then I'll write some method to go to the database and get that information, and then call a bunch of sets on that new instance to set that information, right? Kind of makes sense. And that's good. That's great. That's exactly how you would do it, actually. Okay, it makes sense. The question is, where do you put that utility method? Where do you put that utility method to go to the database and get that information to load up the instance with it, right? Where'd you put that? You could create a utility class. You create a class with a bunch of static methods saying, go get the product, okay? Go get this product or whatever, okay? A really good practice is to put those utility methods as static methods or class level methods on the model, okay? So you have a bunch of getters and setters, but you also have a bunch of class methods to do that initial fetching of information, okay? Now, here is where Rails really kicks ass. This is where Rails really is like Oh, why doesn't every language do this for me? Okay. All traditional Rails models extend a class called active record base. I had a question about what this double colon meant. Again, it's namespacing. So there's a namespace called active record, and inside it, there's a class called base. Okay. That class that we extend gives you an inordinate amount of free methods that you don't have to code. Every database column that you have, every property that you have created for this model, it'll automatically create a getter and a setter for you. You don't have to create getters and setters. They're automatically there for you. So if you say, I want a model that has a name, a part number, a color, you automatically have getters and setters for all those values. You actually even have methods that save itself to the database. You actually have methods, class level methods, that fetch information from the database. Okay? You have all of these methods for free. Now, if you guys were paying attention and listening closely, those are all the methods I talked about that a Rails model would do. So what's left to code? What else are we going to code? To be honest, nothing. If we create a class that extends active record base, you've pretty much got every method that you would ever need for a model. So this is what your class ends up looking like. Class product extends active record base, end, and you're done. And there is so much included in that. Look at all the stuff that I can do. I can call product.all. And what that'll do is it'll go to the database and fetch me all the products, instantiate them into product objects, and put them in an array and spit it back to me. That's for free. You can do things like product.find. Okay, you specify an ID of a product, and it'll go find that for you. Do all the database fetching, put it into an instance of product, and spit it back to you. Okay? You can even do find by. You can find by any column that you create. You create a name, a color, an age. You can do find by age, find by name, find by all that. All included for free. You guys are going to hate Rails when you go do your database class, because you have to code all this manually in Java, unless you use things like, what's that Java database framework? No one knows? Okay. Good, you don't know that. It doesn't exist. Once you have an instance of this model, again, you get all these things for free. You get a setter. Now the setter takes on a very nice looking public, it looks like a public variable, right? Dot name equal, it looks like a public variable that you're assigning. You can look at it that way. To be honest, it's not technically a public variable. It's actually a method, okay? But you get all these setters for free. You get all the getters for free. And you get methods like this for free. .save, which will actually get all your instance variables and save them to the database. And you get methods like this, product.destroy, which destroys the record in the database. All for free. You guys don't have to do a single thing. Okay? That's what your Rails model is. Active record is one of the coolest classes ever. I know that sounds pretty nerdy, but it's true. I am going to introduce to you guys a subtle Ruby nuance when we do this, because you're going to see me type it a lot. In Ruby syntax, okay, when you call a method, as long as it's not ambiguous, brackets are actually optional. Okay? So if I have product.all with brackets, that's the method call. You can technically remove the brackets. It's optional. Even with arguments, product.find2, you can just remove the brackets. Now, if you have arguments, make sure there's still that space there. Okay? Well, actually, we won't get into the last point. The last point's a little bit overkill. Okay, that's the Rails model. All right, everybody stand up for a second. Okay, everybody stand up. All right, you too. Yeah. All right, you are going to give 2 people a high five. I don't care who it is. Go. Woo. High five, you are. All right. Okay. Awesome. Sit down.
Good job, guys.
All right, just little break, a lot of theory. High five for understanding Rails models. Don't forget, Rails models have two pieces. A Rails model and a database migration. We just talked about the Rails model. What about the database migration? Can somebody explain to me what a database migration is? Yeah? No?
Is it just like a way to migrate a database?
Technically, yes. It's a way to migrate a database. Someone else want to take a stab?
You create or delete tables when you do with database migration so that everybody notices that, and it goes to the source code so that nobody misses that. And
That's pretty solid. That's a good reasoning behind database migrations, okay? I'm going to restate it one more time. Database migrations are just scripts that you can run on a database server to create tables, to destroy tables. They're just scripts to actually create, destroy, alter database tables. So we will create a database migration, okay? Something that you guys should have been thinking in your heads is, how do we run that migration? We have the script. How do we actually run the script to actually create the database table, right? So if Kevin checks in that script, I'll be saying on my computer, oh great, there's that script. How the heck do I run it? Right? How do I run it? Rails ships with a script called db migrate. This is all you have to do. From your Rails root, you type rake db migrate. What does rake stand for? Ruby make. It's like a make tool, okay? To be honest, I think Rails 5 is actually replacing this. So if you get to Rails 5 coding, you actually won't see rake. I think they moved everything to just the Rails keyword. But for now, if you run rake db migrate, that will execute the migrations. That guy deserves a sticker, actually. But yeah, the ON guy who answered the what a migration is. Rake db migrate. Now here's the really cool thing. Rake db migrate is smart enough to know what migrations you've already run. So if Kevin sends me the code today and he created a products table and I run rake db migrate, and then tomorrow he sends me a users table and I run rake db migrate, it won't rerun the first one. It knows what ones have run already. Okay? But if somebody else joins and they didn't update it the last 2 days, okay? Yeah?
You can finish. I want to ask a question.
Okay. You can figure out 2 days from now, somebody else picks up the code, they hadn't run either, they'll run all the ones that it hadn't run before. Okay? It's smart enough to know what migrations you've already run on your database. Question?
So does that mean that you have to run this command only when your database is up and running?
Yes, basically. Well, the question is, do you have to run this only when your database is up and running? Okay, what do we mean by our database up and running? Remember I said databases are just like programs. They're programs that are serving up your tables. Okay, do you have to wait for that to be up and running? The answer is yes. Okay. The catch to that answer is that the database that we're all going to use in this class doesn't actually have a running server. Okay, it's what we call a serverless database. It doesn't actually require you to have anything up and running. Okay, it just writes directly to a file and from a file. Okay, but basically, yeah, the answer is yes. You'd only run this if you're using Microsoft SQL Server or Postgres or MySQL, whatever. That database server better be running before you run this script. Okay, so there's a lot of theory. Recap 3 things. 1, a Rails model is basically a model class and a database migration. Okay. 2, the Rails model extends Active Record Base, which has a bunch of methods for free. Just because you're extending that, right, it inherits all those methods. 3, to run a database migration, you have to run this command. And then your table is created, and you can read and write from that table. If you don't run this command, your table will be missing. And when you go to run a bunch of commands like save to the database or read from the database, it'll say this table doesn't exist. You haven't actually created that table yet. Okay? All right. Last thing before we get to the coding. Almost there, guys. Almost there. Okay, last thing. How many people have written a Java class? How many people have ever instantiated a Java class? How many people have ever created a UI that has a button on it? What about a text field? What do you guys use today? Swing?
Oh, yeah.
Swing or AWT, right? Cool. How many people have ever written a Java class and they want to test out the Java class before they build up the whole UI? So what they do is they create like a dummy button or a dummy text field just so we can hit certain methods of a Java class. Good. How many people do, instead of doing that, write unit tests to test their Java classes? I don't actually either. I usually use that first method. Like once I've written a class and I think it's pretty good and it's ready to test, I usually do some system.print lines to make sure it works. Or I create some UI to interact with that piece so it works, right? And I kind of do my testing that way. I kind of build a dummy UI, or I build a dummy public static void main to kind of test that class out, right? And do some dummy code in there, right? This is a very common practice for programmers. We do it all the time, right? The good ones write unit tests. I'm not a good one. This is why Rails is awesome yet again. If you can't tell by now, I love Rails. Rails ships with a tool called Rails Console. And what it is it's a place where you can run all your code just by typing in commands. So rather than creating a button that executes this line, then this line, then this line, you just fire up Rails Console and you type in those lines of code. And you see what happens. So any methods that you create, any classes that you create, you can just play with them in the Rails console. And it's live code, which means if you want to test that it writes to the database, you just write it, .save, and you check your database. Does your database actually have that information there?
That spoiled me so much.
Rails console is incredible. There is another tool that Ruby ships with, by the way, called IRB, that some of you may come across. IRB is called Interactive Ruby. The only difference between IRB and Rails console for our intents and purposes is IRB is straight up Ruby code. So you want to test out how to add numbers in Ruby. You want to test out loops in Ruby. You can do that in IRB. Rails console is one step above that. You can do all that Ruby testing, but also all your classes, all your methods, all those things that you want to test out, you can do it in Rails console. Rails console loads up your entire development environment. Okay, so all your classes, all your methods, you can test them out in Rails console. All right, it's really sweet place to play. And this is what we're going to use. We are going to create our model, and then we're going to play around with that model in the Rails console. Once we know and we get familiar with that model, we know all the code is working, we know everything and how it works, then next week, we use that model in our actual controller code. That's where we're headed. Okay, so first this week, let's code the model and figure out how that model works. Let's play around with the methods. Let's see how it actually behaves, okay? So, fire up vagrants. We are now coding. I'm going to go through it in less than 35 minutes, hopefully. And remember, we're around after class, so if you fall behind, you can follow the notes. The notes are right there, okay? So fire up your dev environment, get your Sublime open, get Vagrant up, and then Vagrant SSH into your virtual machine, okay? But don't start your Rails server. We don't actually need that to happen today. If you've already done it, that's fine. You can always just start a new Vagrant SSH session, get into there, okay? Now, remember, and this is like probably the second or third time I've said this now, all our work is relative to your Rails root, that My Website folder. Everything we do is relative to that My Website folder. Okay, so I'm gonna fire mine up here. All right, so my Vagrant up is running right now. And I'm gonna Vagrant SSH into that machine. While I'm Vagrant SSHing in, I'm going to open up my Sublime. Okay, just get Sublime going, and open up my my code there. Give you guys a little bit of time. Yes, question.
Is it case sensitive for like string, text, all of these?
Like Ruby in general?
Yes.
Is Ruby in general case sensitive? Yes, it is.
Yeah, so spelling is important.
Spelling becomes very important, actually.
You didn't install that vagrant in my machine, so should I just open the?
You should just go to that folder in your terminal and then go from there. Yeah. Okay, how many people are SSH'd into their machine? Okay, I'll wait a little longer.
And what's cool, guys, if you actually spend the time now to learn this framework and you go through everything that's Casey's been putting up, learning other frameworks becomes like a walk in the park. So everybody else uses the same techniques. Everybody uses the same like language. So it's really nice that you guys are going through it. I know it's a little bit boring at first, but like it's the same everywhere. So just learn it once and you don't have to learn it again.
The thing you'll find is that when you go to frameworks that don't have these conventions, is that you'll want to code them in. One time I was working on a C# project, and I was starting to code a model, and what I found is like, okay, what method do I need? Oh, I need this. Yeah, I need that. And then I realized, oh, this is all my Rails stuff. So I ended up just coding all those methods in the model. Because remember, Rails is built by very good software engineers, and all the methods they give you and everything they code for you is based on very good practices.
And you can actually follow along on open source. Like Rails project, they actually have debates. They like a lot of contributors out there, and you can actually follow along like their line of thought. So it's very active, and it's really nice to see.
Okay, how many people are SSH'd in? Okay, let's go forward just because we're running out of time here. Okay, so once you're SSH'd in, remember, go to your Rails root. So cd/vagrant/my_website. Now, when you do that command, always make sure you're actually getting to that directory, okay? You'll see what directory you're in there. Okay? All our command line stuff happens from here. This is where you launch your Rails server, right? Okay, so let's build our model. So we're going to use the code generator. That's going to give us two things. What's the first thing that's going to give us? Model. Good. What's the second thing that's going to give us?
Database migration.
Good. Database migration. Awesome. And give him a sticker. This guy here. What's your name again, sir?
Patrick.
Patrick. And you said something too, right? Yeah, you? No? Somebody over here. You? No? All right.
No.
Whatever. Okay, we're in our Rails root. Let's use our code generator to do this. Remember, you can do this manually by hand, but we're going to use a code generator in this case, okay? So, Rails space generate space. Really check your spelling on this, guys. Rails generate model what are we creating? Blog posts. Sorry, I forgot what we were building. This is what happened at the last class. We didn't remember what we were building. I just want to follow my notes to make sure I'm coding it exactly how I did it in my notes. Yeah, blog post, okay. So, blog post. Singular or plural?
Singular.
Singular. This is the model, right? So, blog post, the class name. Okay, Rails generate model blog post. And we're going to specify some attributes for this. Or in other words, private instance variables with getters and setters. Okay? Our blog posts are going to only have two things. A title and a body. Okay? Title. What do you think this should be, guys? Int, string, string. String's a good idea, right? So we'll do colon, string. Space. We're going to give it a body. What should body be? Decimal, string, int, string, right? Now, little catch here. I'm actually going to make it what's called text. Okay, slightly different than a string. All that text means is it's unbound by the database constraints. If you don't understand that, just follow on the code. Okay, basically, in the future, if we made this a string, it wouldn't be an infinitely large string. Okay, depending on the database, most limit that to 255 characters. Okay, some limit a little bit higher, some limit a little lower. If we make it a text value, in your Ruby code, you just treat it just like a string, no different than a string. But database has some implications on that side. Okay, so we're going to make that text. Rails, generate, model, blog post, title string, body text. Question?
And with the database stuff, track of the rest of that string?
It will give you an error, actually.
Oh, okay.
It'll say string is too big to store in the database column. Yeah. I've got burnt by that a lot, actually. So typically, if you have things that are storing lots and lots of characters, make it a text. Rails, generate, model, blog post, title string, body text. Okay? I'm going to leave it up there for a while to make sure you guys have typed it exactly how it should be, because there are issues that if you type it wrong, it's kind of annoying to go back and forth. When you're ready, when you are brave, when you're willing to take that step, you may hit the enter key. Watch this fail on me, I bet. Computers are heating up around here.
That's okay. No problem.
Luckily, my code worked. How about yours? How many people did that work for? Good, good. One thing I can't stress enough, guys, as Rails developers, read what Rails tells you. Okay?
Yeah.
There are so many times when you get an error and it's just like, it says it right there. The only language that I've encountered better than Rails at telling you what you've done wrong is React. React is amazing at telling you what you've done wrong. Rails is pretty damn good too. The other thing you should read, though, is what it does when it does things for you, like generate code. This is telling you exactly what it's created for you. It created a file under db migrate called 2016 March 9 at 1:30 whatever called create blog posts. It actually didn't timestamp. It put the timestamp in the file name. A little hint about how rakedb migrates is that timestamp. It also created a file called app/model/blogpost.rb. Can anybody tell me what that is? Can anybody tell me what this is? The DB migrate. That's the migration. And what's this?
The class.
That's the class. That's the model class. Those are the two things we created. It also created two files in the test folder, not the scope of this course. Okay? And in fact, if you go on to learn things like automated testing, you probably won't even use what Rails ships with generally. These are the two files that I talked about that we want to create. The model and the database migration. Okay, good. If you go to Sublime, remember these folders are synced, right? If you go to Sublime, you should find those files. Under DB, migrate, you'll see the database migration. You can even see the code that it wrote for us. This is the script that it's going to run. It's going to run a script called create table, blog posts. Okay, you don't have to understand this fully, but you can kind of get a sense of what it's doing. It's going to create a column called title, that's of type string, and a column called body of type text. And it's going to create some timestamps. Yes?
Can you explain what a table is again?
Sure. So a database, okay, is basically a collection of tables. Think of like Microsoft Excel, right? You're familiar with Excel?
Yeah.
Think of like a database as just a big storage file of a bunch of tables, okay? And in those tables, we're going to store data, okay? So when we go to store blog posts, we're going to be storing a bunch of titles and bodies, right? And each of those titles and bodies is going to be a row in the database. So it's a way for us to store this data so that when we shut down our computer, it's still there. Okay, that's a data tip. Good question.
And like the title on the body would like columns.
Would be columns in that table.
So it's like a way for database to
Yeah.
know where to put it.
It would be the exact same thing if you created a Java class that wrote information to an Excel file. Same thing, basically the same thing.
Is this the migration script that we can run on different database?
Exactly. So the question was, is this the migration that we can run on different databases? Yes, it is. Okay. So you can run it on SQLite, you can run it on Postgres, you can run it on SQL Server. It'll run on all those databases 99.9% of the time. There are subtle differences to each one of those database vendors, so sometimes you have to be wary of that. But in general, there's a layer underneath all this that knows how to write to different databases. Okay? So that's the migration script. That is the model class. If you look at under app, models, blog post, you see our awesomely rich class. There's like nothing in it. Good job, Rails generator. Man, you're awesome. It actually is awesome because it's extending that active record base. It's named properly, right? Singular, upper or capitalized camel case. It's really good. So those are our two files that we generated. Doing well. Okay, so we now need to create our database table. Who remembers what the name of the script is that we run? Rake, good. Rake DB migrate. Rake is the general way to run scripts, and then you specify the script to run, DB migrate. Okay, so back in your SSH session, okay, we have run the generator script, which created these files for us. Now we're going to run any script in that DB migrate folder that has not been run yet. We've never run a script before, so it's everything that's in that folder. And by the way, everything in that folder is that one file, right? So let's run that script. Rake db:\migrate. You guys will learn that colon is this weird kind of like syntax that Ruby uses in occasional places. It's just like camel case or underscore or whatever. Like they like name their like methods like this, rake db:\migrate. This is the main one you're going to run into. Rake db:\migrate. When you're feeling brave, when you're ready to take that step and become the person you want to be, rake db:\migrate, hit enter. Look what it did. Read what Rails tells you. It was running a migration called create blog posts, migrating. It actually created the table called blog posts in 0.06 seconds, finished. Now that table exists in our database. Some of you are probably curious and wondering, I never got you guys to install Postgres. I never got you guys to install Microsoft SQL Server. I never got you guys to install a database, have up and running, right? Alex asked the question, does your database have to be up and running for this thing to happen? I said, yes. I never got you guys to start that. And no, I did not install it on your Vagrant machine. I didn't do that, okay? That's because Rails actually ships with a very, very lightweight database that doesn't even have a server running on top of it. It's called SQLite. Android apps use the same thing, SQLite. Okay, so this is a lightweight database. Doesn't have all the complicated fancy things that Postgres has or Microsoft SQL Server and stuff like that. Okay, it's just a simple file that can be interacted with like any of the other databases and that you read and write to. Okay, if you're curious, not crucial to understand this course, that file actually sits in your source code, but you don't check that in. Okay, it's actually under DB, and then this development.sqlite3. This is the database file. Obviously, you're not going to read and write to it like this, right? You let Rails handle the reading and writing of this data, okay? Just if you're curious, little side note. If you don't understand that, let's get back to what we're dealing. We created the model, we created the migration, and we ran the migration. If I run rake db:\migrate one more time, what's going to happen? Nothing. It ran the migration already. It should be smart enough to know that it ran it already. So you can run this as many times as you want. So kind of a good practice when you're coding with other people, just run RakeDB migrate, get your database up to date. It's not going to hurt it if your database is already up to date, right? Look, nothing happened. No output. All right? RakeDB migrate. So we have our class, we have our database table, we have everything we need to use this model. Okay? So let's play around with it. And we're going to play around with it in the console, the Rails console. All right? So how do we start the Rails console? Very similar to the way we start the Rails server. So we type Rails. Instead of server, we type console. You ready to impress your friends at cocktail parties? Most Rails commands, you don't need to type out the whole word. Most Rails commands, you can just type the first letter. Rails server, you can literally just type Rails S. That'll work. Rails console, you can type Rails C. That'll work. Rails generate model you can type Rails G and then model All right? So now that you can impress your friends at cocktail parties, I'm not going to do it in case anybody misses that step. Okay, but you could type Rails C and it'll work just fine. Rails console is going to fire up and it's going to load up all the Ruby on Rails classes, all the Ruby code, and any classes that you've coded, like our blog post model. Here we are, it's waiting for our command. So we can type any Ruby code here. Let's create a variable and assign it a value. Okay? In Java, you'd probably type something like int I equals something, semicolon. Ruby is the most minimalist language in the world. It says we don't need your type. We don't need semicolons. That's stupid, right? So we will type just the variable name. We'll call it A. And we'll assign it a value, 5. What semicolon needed? Nothing, right? Create a variable, assign it. Now, there is a subtle, I would say subtle nuance. It's like my new favorite phrase or something. There's a subtle nuance to the Ruby language that you guys should know. Every statement in the Ruby language, whether that be an assignment statement, whether that be an if statement, or a loop statement, or a switch statement, or a method declaration, every single statement in the Ruby language technically has a value. Okay? Everything you type in an if statement has a value. A loop has a value. An assignment has a value. Now they behave in different ways, but they technically all have values. What Rails console is telling you is if I evaluate the line that you just typed in, this is the value I get back. Okay? So an assignment statement takes on the value of whatever you assign. You don't need to know all these things. I'm just saying this so you understand what this line is. Okay? For example, if statements don't actually, their value that they return is nil, which is the equivalent of null in Java. Okay? I think loops also have a null value. Okay? So you'll see that come up. Okay? Let's assign another variable. And we are coding Ruby. We're technically coding Ruby last week too. We're coding classes and defined methods and stuff like that. We're coding we're coding Ruby there as well. Okay. Can you guys guess what I'm going to do next to those two numbers?
Add them together.
Add them together? Damn. All right, let's add these numbers together. A plus B. Booyah. We could assign that value to a variable if we wanted. C equals A plus B. Bam. Now the C variable, if you just type C, that has to evaluate to a value as well. That has a value. Because all statements in Ruby have an inherent value, you can just type variable names and Ruby will spit back the value that you need. Okay? So that's some Ruby code. Let's do an if statement. If, guess what? Ruby doesn't need brackets around its conditions because it's minimalist. It basically, if Ruby ultimately had its way, it would say, guys, don't code anything. We got this. Right? All right, if C is greater than 5. Now remember, Ruby uses start statements and end. There's no curly braces, right? Okay. So when you hit enter, the Rails console is smart enough here. It knows you're not finished the statement because all if statements need an end statement. So whenever you get to this question mark, you know that you haven't finished the statement somewhere. Maybe you started a string and you didn't close the string, stuff like that, okay? So if you're ever doing the Rails console and you're like, holy crap, like, I can't get anything to work, chances are you're probably in this question mark state. Because Rails is smart enough to know that you started a statement, but you haven't actually quite finished it yet. Okay, if statements, loops, all these kind of things, right? It knows it's smart enough to do that. Okay, so if c equals 5 is greater than 5, we are going to use something that we only use in Rails console. You'll never use this in the actual Rails code. Put s means put string. Okay, it just means output that string to the screen. Okay, it's kind of like system.println, system.out.println. Very similar. All right, so here we'll do, hey, your value is greater than 5. Now, put s is technically a method, so you could have had brackets around it, but remember I said brackets are optional. All right, enter. We all know what if and else is like, right? So why don't we do an else as well? Else, put s, your value is less than 5 or equal to it. Weird way to word that. Ruby is still like, hey, you still haven't really finished this if construct. We need the end keyword to finish it all off. There we go. Now, the only thing I don't like about Rails console is it doesn't do indenting nicely. Right? Typically, you would have if, else, and end all lined up, and then these two things put in, whatever. That's the only thing it doesn't do very well. Okay, but we're just testing code here, so it doesn't really matter. So you see what happened is it ran this if statement, and it put s out to the screen, hey, your value is greater than 5. But the actual value of this if statement is nil. That's why you see nil. Okay, Ruby can evaluate the entire if statement. The value of that entire if statement is nil. Okay. All right, great. You wrote your guys' first if statement. Let's write a loop. I so rarely write real from scratch Rails roots or loop, sorry, that I usually have to look it up. Right, there we go. Okay. So let's write a range, 0.5. Just like we have ints and strings and decimals and floats and arrays, in Ruby, we have something called a range, 0.5. So we're going to range from 0 to 5. This can take, you can call a method called each on it. Now, unfortunately, I do not have time to explain what the next construct is all about. Just code along. For the first couple of months to years of Ruby on Rails development, you can not really understand what this means, but follow the format and you'll be fine. Okay? That's what I did. For like a year, I didn't understand really how this works. Just follow along. If you understand the syntax, you'll be good. Sorry, if you can follow the syntax, you'll be good. Do I. All this means is we're going to loop through 0 to 5, and under each iteration, that variable I is going to take on that value. Very much like a for loop, right? For I equals 0, less than 6, I plus plus, right? All right, let's go into the loop. Now we're inside the loop, okay? So let's just output I, put S, I. And then we'll close off the loop with end. Okay, output 0, 1, 2, 3, 4, 5. And what's interesting here is the value of this loop statement is the range, 0.5. Usually those values of loop statements and if statements, stuff like that, you don't really use, to be honest. Again, the only reason I mention it is if you get confused for what that double arrow thing is in Rails console.
Why did you put the 2 lines beside I?
Oh, yeah, it's a little bit beyond the scope of this, but you could put any value, any variable you want in there, okay? And you have to surround it by those 2 pipes, just the way the syntax works, okay? So if you ever want to do a loop, just follow this kind of syntax.
And it automatically increments I.
Yeah, exactly. Yeah. Actually, it's because we're calling it on each. Each knows to increment I every time, basically through that. Okay. Okay, done a couple of Ruby code. If you're ever curious about a Ruby statement, just run Rails console and type it in. It's like, oh, how does that array method work again? No, just type it in and you'll figure it out. Okay. All right, we have 7 minutes. All right, we've played around with Ruby. Let's play around with our actual model class. That model class that has all those free methods. Okay, so we have a blog post. Class. Let's instantiate that class and create a new one. Okay, how do we do this in Java? We do something like we do like blog post. Blog post 1 equals new blog post and bracket, and then we pass in a bunch of variables, right? This is what a constructor statement looks like, right? Not too different from how we do it here. Okay, first of all, we don't need the variable types in Rails or in Ruby, so we don't need this thing up here. I'm just going to deal with one blog post in this session, so I'm just going to get rid of that _1. It could be any name you want, right? That's just the variable name. Okay, and it's just the constructor is just a method on the class. Okay, it's not a special keyword new. It's just the method new on the class itself. Okay, so it looks like this. Look at that. Okay, technically it looks like this, right? It's a method call. Methods are always optional brackets. That's how you instantiate a class in Ruby. Class name .new. Ruby does have the ability to have specialized constructors if you want to pass in arguments. Okay, we're not coding any special constructors in here. We're just going to create an empty instance and then use getters and setters on that. Okay. So blog post equals blog post.new. You see what coding conventions does, guys? If I ever come across this word blog post, I know I'm referencing the class. If I ever come across this, I know I'm either referencing a method or a variable. Okay. All right, enter. We have instantiated an in-memory blog post. Okay, let's set some values on that blog post. Blog post, free, like set name, set age, whatever. Okay. The way they've coded it is they made them look like public variables that you can just set equal to. Okay. So .title equals. Believe it or not, that's actually a method. Okay, and we're going to set it to my first blog post. See how we're playing around with the class? We no longer need to write dummy UIs or anything like that. We just play around with the code right in there. Because if you were to call a method that doesn't exist on it, it would give you like a no method error. If blog post was nil and you called .title on it, it'd be like null pointer exception. Right? Stuff like that. All right, let's assign the body. Blog post.body equals, I was reading this great article about Rails. Okay, we're using the setter methods on this. So we have this in-memory object sitting on Rails. We can also use the getters. Okay, so why don't we put S, one of the, like the title, for example. Put S, blog post dot title. Okay, question.
I just noticed a little detail. When you did, like when you assigned this to the body, it printed the quotes, but up top when you did puts, it didn't print the quotes. Is that like that's strange?
Here?
Like no, it's gone now because you entered another line.
Oh, okay.
But up top when it said having greater than 5 or something like that.
Yeah.
and then it didn't have the quotes, but then now when we assign for the body, it has the quotes.
Yeah, that was because we're using put s.
Yeah.
Yeah, so put s is just putting the string to the screen. Yeah, whereas this is evaluating the string itself. Yeah. Okay, so we actually use the getter here. So anytime we need to get the title, we just do dot title or dot body to get that. So anytime you need to use that value, just do dot that, and that's the getter. Okay. Now, if I shut down my computer and I restart this all, we're going to lose this blog post. So let's save it to the database. First of all, let's make sure everything looks good in that blog post. Really easy way to check your variable values. Just type the variable and hit enter. Blog post, enter. I can check everything that's in my variable. All right, this is a blog post instance. Its ID is nil, its title, its body is this. Created at, updated at. You guys should be asking, I did not ask for an ID. I did not ask for created at. I did not ask for updated at. All I asked for was for title and body. What are these other getters and setters on this variable? Ruby on Rails conventions. Ruby on Rails says that every database object should have an ID. It should have a numerical incremental ID. It also says you should always have a created at timestamp and always have an updated at timestamp. So Rails by default says any model you create is going to have those three things: an ID, a created at, and an updated at. Okay? Whether you like it or not. If you don't like it, there are ways around it. Don't worry. This is why Rails is great as well. Okay, so we have that in memory. Shut down our computers, go home. We lost it. Let's save this to the database. Let's write this to the file so that when we bring it up again, we'll be able to find it, okay? So, blog post.save. This is a very complex method that creates a database statement to insert all these values into a database row. Okay? And what's pretty cool about Rails is it actually tells you what that statement is. When you guys learn SQL in database class, you'll understand this statement. Okay, this is another language that we don't teach in this class called SQL. Okay, and that actually saved it to the database. So if you shut down your computer now, that's saved. It's in the database. You can retrieve it at any time you want. So, yes, question. Where is it saved? It's that file, that development.sqlite file. This file. It's written to this file. Now, typically, if you have like Microsoft SQL Server installed or Postgres installed or any of the other, they save it in their own area. Okay. SQLite, we actually save it in the same folder structure. But typically, this is sitting completely somewhere else. Like Microsoft SQL Server, Postgres, they manage their own data files. So when you write and read from them, they're managing all that yourself behind this like application layer.
But also just files.
Yeah, but it is files in the background. Yeah. So basically, databases are just a kind of structured, unique way to interact with that. Okay. Okay, so that's that. Okay, I'm gonna go really quickly here. How many people have to run? Just show of hands. Okay, we'll try to get this wrapped up in 5 minutes. Okay. So that is saved to the database. So like I said, if we shut this down and restart it, that information should still be there, right? So let's shut down this Rails console. Okay. So if you type exit, that's going to stop your Rails console. That's like stopping your Java program. Okay? We stopped the Rails console. Okay, so let's start up the Rails console again. Now, if I type blog post, okay, it said there's no variable defined called blog post. Exactly, that makes sense. All that variable work that we did, it's not there anymore, right? All that in-memory stuff we did, it's not there anymore. So that's why you get this big error. Undefined local variable, a method called blog post. Okay? So how do we get that information from the database, load it up into an instance of the variable, and so we can play around with it? Okay? Yes, question?
No, I thought like you were asking a question.
Oh, no. Rhetorical question. Right, how do you do that? Remember, the idea is that you would instantiate a new object, you'd write some code to go to the database to read these values, and use all the setters to set them in there. Luckily, Rails has these methods for us. Okay, so the way we can fetch every single record in the database for a given table is we call the class name dot all. At the class method on the model, okay? Maybe I'll bring that up a little bit. Blog post dot all. What that's going to do is going to go to the database, fetch all the records, put them into instances of blog post, and put those all into an array. So if they're in an array, maybe we should trap that array somewhere so we can work with it, right? So let's assign that to a new array. I'll just call it blog posts. That makes sense, right? We have an array called blog posts. Whatever blog post on all returns, throw it into that array. Enter. So that actually went to the database, interacted with the database, got all the rows in the database, instantiated a blog post object for each one of those records, called the setter methods for each one of them, put all those into an array, and spit it out for us. So blog post is that array. So just like any other array, we can access the elements of that array, right? So blog posts, element 0. Okay. That gave us the first blog post in the database back. What about the second element of the array? Hill. That makes sense, because we only had one record in the database, right? So blog post.all, again, goes to the database, fetches all the records, instantiates all those variables, puts them in an array, and sends it back to us. So now we have blog post sitting in blog post in that array. Let's play with it, right? So we can take that blog post and assign it to a variable. Right? The first element of that array, assign it to a variable called blog post. If there ever was any value in there, just overwrites it, right? Basic programming, right? Variable assignment, right? So now we have that blog post, and we can play with it the way we played with it before. Blog post.title, blog post.body. All the information is there that we saved. So I showed you one way you can get all your records from the database. I showed you a way you can save your records to the database. I'm going to show you one last way that you can fetch a record from the database if you know the ID. Okay? So if you happen to know the ID of the blog post. So in this case, I do know it. Blog post 1. All right, ID number 1. The next one you'll save will be blog post 2, 3, and 4, and so on. By the way, this is an incremental counter, so even if you delete some, it just keeps going up. Okay? Now, normally we wouldn't do this because we already have the blog post in memory to deal with. Right? We already have it. So we can play around with it. But just for your own interest, if you want to fetch that specific one, there's another method you can call to get that specific blog post. And that looks like this. Find, and you pass in the ID. Okay? It's going to go to the database, grab the information out, instantiate it into an object, and return it to you. Okay? I want you guys to remember that the whole reason we're doing this is that we can't deal with objects when they're sitting in the database in their tables. We like to work with objects, right? We program with objects. So when you want to work with an object, you have to get it out of the database first and get it into an object that we can play around with. Because we know how to work with objects, right? Getters, setters, all that stuff. We know how to work with that. We don't know how to work with like this stream of, you saw those bits and bytes, right? Like it's like you can't work with that. So we get it out of the database into object form and work with it. And then when we're done with it, we save it back to the database and shut down the computer and we're done. Okay? The last thing I'm going to show you is how to destroy this blog post from the database. So if you type blog post.destroy, that removes it from the database. Now what's interesting is you still have it in memory here until you shut down your computer. It's still sitting in memory, but it's gone from the database right now. Okay? Now your database is empty again. If I were to call blog post.all, you'll see it's empty. It's empty now. Okay. Okay, thanks guys for sticking around. I know there's a lot of theory. Your homework is to create 5 blog posts using the Rails console and then delete 1. Okay? When you come to class next week, I expect there to be at least 1 blog post in your database. Okay? Remember what I said about the Rails console. It's live code. So this database that we're hitting here is the exact same database you're going to hit in your actual controller code and stuff like that. Okay? So homework, again, it's all in there. We'll be around for the next little while. But you have to create 5 blog posts, destroy 1, play around with updating and saving those blog posts, shut down your computer, wake up the next morning, try to get those blog posts back. Play around with that Rails console. Okay? Thanks so much, guys. Next week, we tie it all together. Cool. Question? Sorry, there's a question? Yep.
It's about the homework from last week.
Okay.
I wanted to show you.
Sure. Well, I'll come talk to you.
Thank you, Casey.
Yeah. Again, remember all my source code is on GitHub. caseylee.com/tutorials. Scroll down, class source code. You can get to it. I'll get to you in a second.
Is it something?
Oh no, sorry. Yeah, so this is only like that. It's only like a slash. Like Java, but I know like this right here. Okay. Think of this. It's just a shortcut. Like this. Right? Okay. So that means when you type in the URL, it's going to go to.
I was like, maybe
So that's what this is.
And then they go.
That means when you type in slash, it goes to the page. You can only have one of those routes. You can only have one.
so that when you the homework part,
Yeah.
when you feed the rows, you need to do this.
Exactly.
It's not.
So that'll create a route. Yeah. Does that make sense? Because you can't have it go to 2 different places. Cool.
If you exit now,
Like this means there is my homepage only, but I'm specifically clicking on home that's showing.
Do you, what, we have DGD tomorrow?